Hi everyone, this is Kevin from Knowledge Scroll, and in today's video I'm going to do a quick run through of some transformation questions. This is just a quick review of this topic in general, going through a few CSEC past paper questions. In this first question, this question is from 2016 paper. Here we have two triangles RST and R prime S prime T prime, and we are asked to describe the transformation that maps this first triangle onto this second triangle. Whenever you're describing a transformation, there are several ways you can do it. There is an easy way, and then there is also the better or more correct way, which is in the form of a vector. If you look at these two triangles, I'm going to choose a single point, maybe S, and all I'm going to do is I'm going to count how many spaces does it take to S to line up with S prime going across, and that is 2 spaces or 2 hops. And how many hops coming down till it reaches S prime? 1, 2, 3, 4. So it was 2 to the right and 4 down. So if you have a transformation that is 2 to the right and 4 down, you can express it simply as a vector 2, and because it's going down, -4. So this is the transformation. It's moving 2 to the right, 2 spaces, to the right, and 4 spaces down. And that is how you can describe this transformation. Another way you can describe the transformation is using this notation here. Let me change the color. So let's say the transformation T, and this transformation is called a translation. Translation just means movement. So capital T for translation of X and Y, meaning you're translating or moving the X and Y coordinates such that it moves on to X plus 2. Means all the X values you add 2 to it, and all the Y values you subtract 4 from them to move to the new location, which is from here down here, and it corresponds to every point. If I check for R, 1, 2 across to the right, 1, 2, 3, 4 down. So these are the 3 ways you can describe a transformation. Now the next kind of transformation we're going to discuss is one called a reflection. A reflection always occurs about some kind of mirror line. Like if you're looking at a mirror, the object is going to be oriented facing the other direction depending on where the mirror is. Now all these questions that involve reflection, either you have to find the mirror line, or you have to draw it in yourself, or you have to state the coordinate after you reflect it. In this particular question, it says the mirror line is x equals to 6. Now, therefore, you have to find the x line that corresponds to that. So the x line, x equals to 6, will be the line that is passing through 6 on the x-axis. So let me get the ruler tool. You'll need your ruler in the exam, and you put your ruler here on 6, and you draw a vertical line that passes through 6 here on the graph. So this red line here is my mirror line that I will reflect all of the points across. Now when you're reflecting across the mirror line, you must pay attention to the space from the line to each point. For example, if S is 1 space away from the line, then it must be 1 space away on the right side as well. And this is where S double prime will be. If R is 1, 2, 3, 4 spaces away on the left, then on the right of the mirror line, it must be 1, 2, 3, 4 spaces away here on the right. So this is where R double prime is. And last question is T. T is just 2 spaces down from R and is still 4 spaces away from the mirror line. So this is where T double prime will be. Now all that's left to do is to draw in your triangle. Obviously use a ruler in the exam. Alright, so once you draw in your triangle, this is your reflected image. Just one more thing I want to point out. If the question says reflect in a y line or y equals line, then you have to look for the horizontal lines. For example, if it says y equals to 1, this is a horizontal line that you should reflect across here at 1. If the question says reflect in the line y equals to 0, that would be essentially the x-axis line that you're going to reflect across coming down. So you have to know what your x lines are and what your y lines are in these questions. Now the final question on this exercise says just simply state the coordinate of r double prime, and of course they did not fill in this scale completely, so let's fill it in with 10. R double prime has the coordinate of 10, comma 3. So that is where your last mark will be. The coordinate is 10, comma 3. And that is our first question completed. Now this next question is also another reflection question, but it's different from the one that we had before. As you can see, we have the original triangle over here, JKL, and it is reflected over here in this bottom right hand quadrant as J prime, K prime, and L prime. Now this particular reflection is a reflection across a diagonal line. So let me see if I can draw it in for you. So this diagonal line is my mirror line, and this line has a particular name. This line is called the line of y equals to x. As you can see, if x is 1, y is 1. If x is 2, y is 2. The line goes perfectly through the origin, which is right here, 0, 0. Now the first question simply asks us to state the coordinate for the vertex j. So j is negative 4, comma 1. Pretty straightforward question for 1 mark, negative 4, comma 1. In fact, I'm going to put all of the coordinates for the first triangle here on the side because you may need that later on. So j is negative 4, comma 1. We have k being negative 1, 1. So I'll write it here as well. And I have L being negative 1, 3. Negative 1, comma 3. Now question 2 simply asks for the length of the side K prime and L prime. So the length of this side here, if you count these spaces as centimeters, this answer should simply be 2 centimeters. At least that's how I interpret this question to be. Now it says describe fully a single transformation that maps JKL onto triangle J prime, K prime, and L prime. Now we're going to explain everything I just said in simple words. This transformation is a reflection about the line y equals to x. So that is what you will say for 2 marks. It is reflection about the line y equals to x. Now for part 4, it says state the coordinates of the triangle J double prime, K double prime, and L double prime, the image of the original triangle JKL under the translation vector 5 minus 3. Now, remember, whenever you're translating, that means you're moving the original triangle 5 to the right, and in this case, 3 down. Now, we may be able to draw it on this graph, but you don't have to draw it. You should just know that the 5 means you add 5 to the x values, and the negative 3 should mean that you subtract 3 from the y values. So I'm going to put this information up here. 5, negative 3 is my translation vector. And how this is going to work is I'm going to map this onto the corresponding point. So over here, you will have J double prime. Let me just change the color in blue. J double prime. If I add 5 to negative 4, I should end up with the number 1. And if I subtract 3 from 1, then I will end up with the number negative 2. So my corresponding point is 1, comma negative 2. And for K double prime, I should end up with, if I add 5, I should end up with 4. And if I subtract 3 from the second value, I should also end up with negative 2 once again. And for the last one, L double prime, if I add 5 to this, I should end up with 4. And if I take away 3 from this, I should end up with 0. So these would be where my translated points will go to. Let us see if we can actually fit it on the graph and see if it can work. So let's see, 1, comma, negative 2. So go across 1, negative 2 would be right here. 4, negative 2, go across 4, come down 2. And this one, go across 4 and go up or down 0. So just right here. And here you can see, I'm going to put it in blue for you. This is where the triangle here would move to under this transformation 5, negative 3. It goes from here, goes 5 to the right and 3 down, and this is where it should rest if you do it properly. So that is how you can translate an object without having to draw it. You can just simply add the values onto the coordinates and you get your corresponding translated points. So now for our next question, this is purely an enlargement question. Now, when you're talking about an enlargement, the two things you must understand is you must know or find out what the center of enlargement is, as well as possibly the scale factor of enlargement. If your scale factor is greater than 1, that means the image is bigger than the original shape. If your scale factor is less than 1, then the image is smaller than the original shape. So let's look at this one. We have two triangles, L, N, and M, and P, R, and Q. Now normally, this P should have been named L double prime or L prime. This M should have been over here. This should have been M prime. And this N should have been, this part here should have been N double prime. But CSEC labels it how they feel to label it. Our goal, of course, is to locate the center of enlargement because it is clear that this one down here is an enlarged version of this triangle. Now, the first question asks us to locate the center of enlargement and show clearly the method by which you do so. And the second question asks us to state its coordinate. Now, to do that, first you must take your ruler and you must line it up in such a way that the ruler is on the original point L as well as the enlarged point P. Now you get your pencil and you draw a line through both of those points. Next, you take your ruler, you place it at N and you align it up with the enlarged point R. Again, you repeat the process, draw a line through both of these points. Finally, we're going to do the same thing for M and Q. Line it up at M and Q. And our final line will look something like this. And where the three lines intersect, let me label it here in blue. The three lines will intersect at a single point, and this is our center of enlargement, and this coordinate here is 1, 5. So we answered both questions A and B. The coordinate 1, 5 is our center of enlargement. Next, we're asked to find the scale factor of this enlargement. Now, to find the scale factor, there are two ways you can do it. You can take your ruler and you can measure from the center of enlargement to the first point and the center of enlargement to the second point, and then you can divide the two results. Or in this particular case, you can just simply count the squares. If it takes 2 squares to get from N to M, and it takes 4 squares to get from R to Q, then this scale factor is simply a scale factor of 2. So in other words, this triangle is twice as big as this triangle. The dimensions of the triangle are twice as big. Now let's talk about the areas of the two triangles. Now remember, the formula for the area of a triangle is half the base of the triangle multiplied by the height. So let's find the area of the big triangle first. So that would be half, and the base in this case is 4 times the height, and this height is 1, 2, 3, 4, 5, 6 centimeters. I'll just leave it unitless for now. So half 4 times 6, this is 12. Let's call it centimeters squared. And for the small triangle, let's try the same formula, half, and the base is 2, and the height is 3. So our area for the smaller triangle is simply going to be 3 centimeters squared. Now, if you realize, although the scale factor is 2, you realize that the ratio or the multiple that it takes to get from the small one to the big one is by a multiple or a factor of 4. So when you do this ratio, 12 over 3, you should get the area being 4 times as big on the big triangle. So that is a point to note. Even though the scale factor is 2, the area is 4 times as big. So now for question part D, it says we're going to draw a new triangle that has these following coordinates. So the first coordinate is negative 4, 4. The second one is negative 1, 4. And the third one is negative 1, 2. So this triangle is something like this. Alright, now right away I can tell that this is not a reflection, it is not a translation. My first instinct is telling me that this is some kind of rotation because the orientation is different. So I'm going to check now to see if I can find the center of rotation and then describe the rotation fully for you. But before I do so, I don't want to lose any marks. So again, you must label the triangle properly. This first coordinate here was A. The second one, negative 1 and 4. This one here was B. And the negative 1, 2 was C. Let's not lose any marks in the exam. If it says label, you should label your diagram. Now, to actually find the center of a rotation, what you can do is first choose 2 corresponding points on the 2 different triangles. For example, I can see that C corresponds with N, and I can take my ruler and I can draw a simple line connecting C to N. Now what you will do is take your compass and you will probably try to draw a perpendicular bisector of that line. In other words, a line that cuts that line in blue at exactly 90 degrees. Now it's hard to do using this platform here, but I can tell that my center of enlargement is going to be this point 0, 0. And if you repeat the process again, for example, if I chose A and L, a perpendicular bisector would be the line coming down here. So I can tell that my center of rotation is 0, 0. It's just that it's hard to do using the tools I have here on the screen, but it is the point 0, 0. And now I'm going to describe this rotation. Now this rotation is a 90-degree rotation and it is going clockwise. So in other words, each point is going to the left. This is a clockwise rotation, and therefore when describing it you have to state as follows: the transformation is a rotation about the point and again the point of rotation or the center of rotation is 0, 0. And the most important word you must say in here, it is an anti-clockwise rotation, meaning it's going to the left, or you can say it is a 90 degree anti-clockwise rotation about the point 0, 0. So these are the important words that you must say. It is a 90 degree anti-clockwise rotation about the point 0, 0. Now, if you are having trouble locating rotations and the centers of enlargement, another way to think of rotations is by using this particular table that I'm going to flash on the screen. When you are rotating a value, for example, if n, the point n was the coordinate 2, 1, and I am rotating this here over to C, what happens to the coordinates? You realize that the coordinate for C is -1, 2. So in other words, the coordinate values flip, and the first one, the x1, turns negative. So that is how you can tell that this is a 90 degree anti-clockwise rotation. So here ends the little review of translations. I hope that this video was helpful to some of you. I can't do any more at the present moment, but I do hope that this is sufficient for you to have a grasp of the topic. Thank you for watching. I'll see you next time. Now, if you enjoyed that video, feel free to like and share it with your friends. You can always visit us at knowledgescroll.com, where you can look at our full list of services that we offer to secondary and high school students. Here's also where you would come to browse our full catalog of featured videos, as well as sign up for any of our reasonably priced online courses. My name is Kevin, and I thank you for watching, and I hope we meet again.